matter around us. What is matter made up of? All matter is made up of very tiny particles. This looks as simple statement, but it is very difficult to explain and understand about matter. For this, we need more details about these particles and their arrangement inside various forms of matter. What is the matter? Meaning of this term is very difficult for scientists than that of a common man. We have read about metals, non-metals, synthetic and natural materials, acids and bases, etc. in previous classes. These are the examples of matter. All the things around us which exist in the variety of shapes, sizes, texture are also examples of matter. The water we drink is a matter. Similarly, our food, clothes, and various things that we use in our day-to-day life, the air we breathe, even our body, etc., are examples of matter. In a simple way, anything in this world that occupies space and has mass is considered as matter. States of matter. We say that solids, liquids, and gaseous are three different states of matter. Water can be found in all these states. Is there any substance which can be found in three states like water? No. We can classify most of them quite easily into one of the three states of matter. For example, you can say that wood and coal are solids and petrol is a liquid. Milk also is a liquid like petrol. But the properties of petrol and milk are quite different from each other. What are the properties that lead us to consider petrol or milk as liquids? For this, let us discuss about the properties of solids, liquids, and gaseous. Properties of solids, liquids, and gaseous. Do solids have definite shape and fixed volume? If we take two solid objects, say a pen and a book, and put them in different containers, do you find any change in their shape or volume? No. This shows that solids have a defined shape and a fixed volume, identifying the shape and volume of liquids. Activity. Different shapes of liquid of same volume. Collect the containers of different shapes available to you and same liquids like water, oil, and milk. Take some water in one of the container using measuring jar. Examine shape of the water in the container. Pour the same water in another container and have a look at the shape again. Repeat the process till you complete pouring water in all containers. What is the shape of the water in different containers? It is different. Is it same in all cases? No. What shape does water take if it's split on the floor? It doesn't take a fixed shape. Take 50 ml of water with the measuring jar and pour it in glass. Mark the level of water in the glass and throw it out. Now measure 50 ml of the milk with measuring jar and pour it in the same glass. Mark the level of the milk on it. Are the levels of water and milk same? Yes. Remove the milk from the glass. Now pour oil in the glass up to the level marked by water. Can you guess volume of oil? It is equal to volume of water. This activity may seem very simple, but we observe two important properties of liquids from this activity. The shape of the liquid depends on the shape of the container. Its volume remains same. Liquids can flow easily from one container to another. They are also called fluids. So, liquids have no fixed shape but have a fixed volume. Activity. Do the gases have a definite shape and a fixed volume? You know about CNG, that is compressed natural gas. Go to a petrol pump and ask them where they store CNG. Also see where CNG is stored in a CNG run vehicle. Lastly, see how CNG from the pump is transferred to vehicles. Does CNG has a fixed volume? No. Does CNG has a fixed shape? No. From the observation in the above activity and with our daily life experiences, we can find the CNG and all other gases neither have a fixed shape nor volume. Activity. Observing the compressibility of different materials. Take 100 ml syringe. Draw the piston to stuck in air. Place your finger on the nozzle and press. Observe depth of piston moved into syringe. It is easy or hard to press? Easy. Do you find any change in volume of air in the syringe? Yes. Now fill water in the syringe and do press the piston as said above. Is it easier to press the syringe with water or air? It is air. Now take a piece of wood and press it with your thumb. What do you observe when you press the wood? It is very difficult to press it. Is there any change in its volume? No. From the above observations, you find that gases are highly compressible as compared to the liquids and solids. Example, in our houses, liquefied petroleum gas is used for cooking. Nowadays, CNG is used in many automobiles. In all these purposes, large volume of gas is compressed into smaller volume to make it potable. Diffusion. Activity. Observing the diffusion of gases. Ask your friend to hold an unlit incense stick and stand in one corner of the room. Then you go and stand in the other corner. Can you smell anything? Now ask your friend to light the incense stick. Can you smell anything now? Yes. When you light the incense stick, The scent in the vapor form and smoke mix with air and move across the room to reach our nose. The movement of air, vapor, of scent and smoke is known as diffusion. In this case, smoke, vapor of scent and air are highly mobile and are in the form of gases. If you spray a perfume or deodorant in one corner of the room, it spreads soon to all directions. Does the smell from burning incense stick and deodorant spray reach someone on the other end at the same time? No. Activity. Observing the diffusion of liquids. Take 250 ml beakers and fill them with water using a dropper and put a drop of KMNO4 solution slowly along the sides of first beaker. Diffusion of potassium permanganate in water. You can observe that liquids also diffuse into each other like gases. Activity. Observing the diffusion of particles of solid into liquid. Take a beaker full of water and add a small potassium permanganate crystal to it. And observe the changes. Repeat the experiment with a crystal of copper sulfate. Do you observe diffusion? Yes. It is faster or slower than that observed in other two activities? It is slower. Now, it is clear that solids and liquids diffuse into liquids and gases diffuse into gases. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. Diffusion, therefore, is a very important process for living things. Oxygen diffuses from lungs into blood. CO2 diffuses from blood into lungs. Diffusion of two gases. Activity. Aim to observe the speed of diffusion of two gases. Material required: glass tube with scale, ammonia solution, hydrochloric acid, pieces of cotton and ribbon cork. Note: they should take care of handling hydrochloric acid and prevent the children from touching the acid. Procedure: take a 1 meter long narrow glass tube. Take 2 pieces of cotton wool. Soak one in hydrochloric acid solution and another in ammonia solution. Put them separately at the two ends of the tube. Block the ends of the tube and observe. The hydrochloric acid gives off hydrogen chloride gas and ammonia solution gives off ammonia gas. Both gases react together to form a white substance called ammonium chloride. Property: solid, liquid, gas. Property: shape: solid, fixed, liquid, no fixed, gas, no fixed. Property: volume: solid, fixed, liquid, fixed, gas, no fixed. Property, compressibility, solid, less, liquid, medium, gas, high. Property, diffusion, solid, no, liquid, yes, gas, yes. Can matter change its state? We started our discussion by recalling the water exists in all the three states. You must have seen many other materials that can exist in different states. For example, coconut oil is usually liquid, but if it is too cold, it becomes solid. Camphor is a solid, but if we leave it in the open air for some time, it directly changes to gas. You may have seen mothballs being placed in clothes. The smell remains even when they disappear. This is because the solid balls have changed from solid state to gaseous state. Solid, liquids, and gases are states of matter, but you need to think about why are the properties of matter different in different states. When does water change into ice and then into vapor? If there is a change in temperature. Why does gases diffuse faster than solids or liquids? Due to their random motion. Scientists have tried to explain these facts by examining the physical nature of matter. Activity. How small are the particles of matter? Take a beaker with water. Mark the level of water. Add 1 to 2 crystals of potassium permanganate and dissolve them in water. What does happen to the color of water? The color of water changes. Now, take out approximately 10 ml of this solution and add it to 90 ml of clear water in another beaker. What does happen to the color of water? The color of water remains same, but some part of it will be colored. Again, take out 10 ml of this solution and add to another 90 ml of clear water. Carry out this process 4 to 5 times and observe changes in color of the solution. Is the water still colored? No. How is it possible for 2 small crystals of potassium permanganate to color a large volume of water? It is possible due to diffusion. What do you understand from this activity? We can understand that there must be several tiny particles in just one crystal of potassium permanganate which are uniformly distributed in water to change its color. So, both solid and liquids are made up of tiny particles. Activity. There exists shape between particles. Take a beaker and fill it with some water and mark the water level. Add some salt and stir it throughoutly with a glass rod. Observe if there is any change in water level. Add some more salt and stir it again. Observe the change in level of water. Does the level of water changes? Generally, It seems to be no, but it changes. What will happen to the salt? It will dissolve in water. Can you see it in the water? No. From the activities 8 and 9, we can conclude that both solid and liquid particles have some space between them, and the solid particles enter into the space between the liquid particles on dissolving solid in liquid. Recall the inch stick activity. Do you agree that gas is also made up of particles and they have large space between them? Activity. Observing the force of attraction between the particles of the matter. Open a water tap and allow the water to reach the ground. Now, try to break the stream of water with your finger. Can you break the stream permanently or momentarily? Momentarily. Are you able to break the stream of water anywhere from the tap to ground? No. What is the reason behind the stream of water remaining together? It remains together because it applies a force. Now, try to break a piece of iron nail with your hands. Are you able to do it? Or does it rejoin? No. What about a piece of chalk? We can easily break it. From the above observations, we can say that particles of the matter have force acting between them that keeps the particles together. It is also clear that its force is not equally strong in all the forms of matter. How diffusion takes place? Diffusion can be possible only when the particles of matter move continuously. In the inch stick activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread along the room. Particles of solids, liquids and gases can diffuse into liquids and gases. Rate of diffusion of gases is higher than the liquids and rate of diffusion of liquids is higher than the solids. There are two reasons for higher rate of diffusion of gases. One is due to the higher spread of gas particles and another due to greater space between them. Similarly, the greater diffusion rate in liquids compared to solids is because particles in liquids move freely and have greater space between them when compared to particles of solids. In the gas, the particles are not as close together as in a liquid. If a colored gas is mixed with a colorless gas, the color spreads evenly in it. This happens faster in gas than a liquid. You can see the diffusion of bromine when it diffuses through air. Bromine is a brownish colored gas. Hence, its diffusion is colorless. Air can be seen clearly. If we allow bromine to diffuse in vacuum, it diffuses faster in vacuum because there are no particles to obstruct in its way. Effect of temperature. Do you guess what happens if water is heated during the diffusion of liquids? You find that diffusion becomes faster. Effect of temperature on change of state. Take about 100 grams of ice in a beaker. Keep the bulb of a laboratory thermometer in contact with the ice. Set up the beaker. Note the temperature. Heat the beaker slowly. Record the change in temperature after every 30 seconds. Let the ice melt completely. Now place a glass rod in beaker and continue heating till water starts boiling. After some time, all the water will be vaporized. Does the temperature change continuously? No. Does the temperature remain constant for a while at any time during the period of heating? Yes. The temperature of the mixture of solid ice and liquid water does not change for some time when it reaches melting point. The temperature starts changing only when ice completely melts. On heating the water in the beaker, the particles gain energy. Due to additional heat energy, the particles move more freely by overcoming the force of attraction between the particles. At a certain temperature, the solid melts and changes into liquid. The temperature at which a solid melts to become a liquid is called melting point. The process of changing liquid into solid is known as fusion. The melting point of a substance depends on the strength of the force of attraction among the particles. The higher the force of attraction among the particles, the higher will be the melting point. The amount of heat energy that is required to overcome the force of attraction among the particles is given by the latent heat of the substance. Latent heat of fusion is defined as the amount of heat energy required to change 1 kg of a solid to completely into liquid at atmospheric pressure at its melting point. On supplying heat energy to water particles, they start moving faster. At a certain temperature, the heat particles have enough energy to become free from the force of attraction among the particles, and the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling point of water is 100 degrees centigrade. Particles in water vapor at 100 degrees centigrade have more energy than the particles in liquid water at the same temperature. This is because particles in water vapor have absorbed additional energy in the form of latent heat of vaporization. So, we can infer that one state of matter can be changed into another state by absorbing or radiating heat energy. Now, we have learned that substances around us change state from solid to liquid and from liquid to gas on supply of heat. But there are some substances that change directly from solid state to gaseous state and vice versa without passing through the liquid state. Sublimation is one of the examples. The particles of matter, irrespective of the state at the given temperatures, possess different energies. For example, in liquids, the particles at the surface possess high energy than particles in the large amount of water. The particles on the surface are able to break away from the force of attraction of other particles and change into vapor state. This phenomenon of change of liquid into vapors at any temperature below its BP is called evaporation. Effect of surface area, humidity and wind speed on evaporation. Take 5 ml of water in a test tube and in a china dish separately and keep them under the fan. Take 5 ml of water in another china dish and keep it in the cupboard. Record room temperatures and time taken for evaporation of water in all 3 cases. If possible, repeat the activity on a rainy day and record your observations. In which case evaporation is fast? What do you infer about the effect of surface R and wind speed on evaporation? You must have noticed that the rate of evaporation in china dish is faster. Effects of change of pressure. We already know the various kinds of states are due to the differences in the distances between the constituent particles. What will happen when we apply pressure and compress a gas enclosed in a cylinder? Will the particles move closer? Do you think that increasing or decreasing the pressure can change the state of matter? Can we liquefy gases by applying pressure or reducing temperature? Recall that solid carbon dioxide is stored under high pressures. Solid carbon dioxide converts directly into gaseous state when the pressure is decreased to 1 atmosphere. Due to this reason, solid CO2 is also known as dry ice. Thus, we can say that pressure and temperature determine the state of the substance, whether it will be solid, liquid or gas. Evaporation. Do we always need it to supply heat or change the pressure for changing the state of matter? Can the change of matter from liquid to vapor take place without the liquid reaching its boiling point? You have experienced drying of wet clothes in air. In this process, water directly changes into vapor form without reaching its boiling point. Since evaporation is a surface phenomenon, during evaporation process, the particles escape from the surface of liquid. The increase in the surface area provides more scope for particles to escape from the surface. Hence, increases the rate of evaporation. Humidity is another factor that affects evaporation. The amount of water present in air is called humidity. The air around us cannot hold more than definite amount of water vapor at a given temperature. If the amount of water vapor is high in air, the rate of evaporation will decrease. So, clothes dry slowly during rainy seasons but fast on sunny and windy days. Because of increase in wind speed, water vapor particles move away with the wind, decreasing the amount of water vapor in the surrounding. Experience with evaporation. Why do you feel cooler after sweating? When you get sweat on working or physical exercise, the sweat evaporates from surface of your body by absorbing the heat from your body. The particles of liquid absorb energy required for evaporation from your body and escape to the surroundings. This makes you feel cool.